Hello everyone. So in this video, we will compare the cable types between the copper and the fiber. First one, we will look into the copper. So you might have seen the standard wires disconnected with the RJ45, the copper cables, which is used in enterprises. You might have seen it. All right. So the copper has the standard of 100 Mbps, 10 Mbps, 100 Mbps, 1 gigs, and 10 gigs. So if I have to write it down, let me just take it and write it down like 10. So 10 Mbps will be so-called Ethernet cables. If you use 100 Mbps, it is so-called fast fast Ethernet. And straightforward for the 1 gigs, which is 1 Gbps, 10 gigs, just Gbps. So 10 gigs. If you are using 10 Mbps Ethernet or 100 Mbps fast Ethernet, you will be using only two pairs of wires. If you're using a gigabyte cables, you will be using the 4 pairs of wires, meaning that so for the transmit and receive the data, um, the great example would be Cat 5, Cat 5, and this one will be Cat 6. All right, so going back to the wiring section, so if you're using 100 Mbps Ethernet cables, only 2 pairs will be used, meaning that you'll be using only 4 of the wires to transmit and receive the data. But in case if you're using 1 gigs and 10 gigs, you will be using all these 4 pairs of wires, meaning that you'll be using 2 pairs, that is 4 wires for the transmit and four wires for the receive. So as you can see, the twisted pairs is so-called unshielded twisted pairs in the copper Ethernet cables. We write it down. So it is so-called UTP, which is unshielded twisted pairs, which has an advantage of protecting it from the protecting against the EMI. The EMI is electromagnetic interference, which is protecting against unwanted noise or interference in the electrical path. Length will be 100 meters for all the copper wires. So meaning that even if you take 1 gig, 10 gig, 100 gig, or 10 Mbps, everything should be within the 100-meter range, else I believe it will not work. So now that we have learned how the copper wire works, we will try to go ahead and connect the devices using the cables and see how it will work. So if you are connecting the same device, you have to connect with the crossover cables. So crossover cables will look like this. So you'll select this one and select the appropriate interface and connect it. So if you are connecting different devices, like I'll take a switch and a router this time. So if I'm connecting a different devices, then I will use the straight through cable, which looks straight. You can actually go ahead and connect with the appropriate interfaces as well. So, so that's it for the straight through cable. In the real world, you don't have to be so much worried about the crossover cables or the straight through cables, because it will be taken care by Auto MDIX, which allows the devices to detect what pin is used by the neighbor, and it will adapt it. And that is the advantage of Auto MDIX feature, which is present in the Cisco switch. So we have seen the details about the copper. We will go ahead and see how the fiber works. So for the fiber, we'll be using 2 different types of fiber cables. Let me show you in the real-time examples. Like, let me bring up the cables first. So in the fiber module, So you have seen it, right? So this is how the fiber cable looks like, with the ends looking like this. So we have two different types of fiber cables, which is MMF, so called multi-mode fiber, and then SMF, single mode fiber. So the first one, MMF, is used for the shorter distance. Say for example, if you want to connect host to a switch or a router, this works. And SMF, we'll be using it for the longer distances. So longer distance, for the longer distances, like connecting the branch offices, like router to router, we can use the SMF. The fiber cables uses SPF, which is nothing but a small form factor pluggable. So let me write it down as well. SPF. The SPF will looks like this in the real world. This is how a SPF will looks like. So what you will do is take this end of the fiber cable and insert it right here, and then the other end will goes into the switch itself. And for that example, let me bring up this one. So like this. So you will, so basically you will insert this tip of it into the SPF one end, and the other end will goes into the SPF port itself. So this is how the fiber cable works in the real world. I just wanted to show you that one. Fiber cables varies from many different speeds, which is 1 gig. It can be 1 gigs gbps, 10, 40, 100, and 400 as well. So the length, it will vary from 5 kilometers to 30 kilometers depending upon the naming standards. So please feel free to search for it. So now that we have seen both of the real world examples, let's compare both of them. So when you compare copper and fiber, the copper will be cheaper as per the cost, has a limitation that you can use only for 100 meters, and also it is giving you an advantage of protecting the device from unwanted noises with EMI. And if you see the fiber, it is high cost, will provide you with a longer distances, and also there is no EMI because the information is passed through the glass, the tip of the glass. So I can actually just show you an example as well. In the real world, the fiber will actually looks like this. The fiber cable will be looking like this. So I just wanted to explain it a little bit more about that one. If you take MMF, which is multimode fiber, the core will be wider and it will allows multiple angles of light to enter through. And if you take SMF, which is single mode fiber, it will be narrow and the light enters in single angle. So it will so for the longer distance, the SMF will be useful. For the shorter distance, MMF will be useful. So as we have seen how the fiber cable works, let's do a practical and understand how the fiber cable works in the Cisco packet tracer. So for that, I will take a PC. So I'm going to connect. This is an example of say MMF. For the MMF, I'm using a PC and a switch. This PTMT. So in order to connect with the fiber cables, we have to add the appropriate NICs in it, network interface card. So for that, power off this PC, take the interface out, and add FGE, which is nothing but gigabyte interface converter, we'll put it and switch the PC on, which we have done. Do the same thing in the switch as well. Switch off the PC, look for the FGE, put the interface in, and power on the device. Once done, look for the fiber cable. It says fiber in here. Click that, connect it with the Gigabyte Ethernet. Same here as well. Once you connect, just fast forward it so the STP will work. And then now the fiber cable is absolutely working right now. As we have seen an example of MMF, we'll see an example of SMF, which is for longer distance. For that, I'll take two routers. This PTMT. PTMT should work as it has the interfaces available here. As you can see, switch off the router, put the FGE interface in, power on the router again, and then we'll do the same thing in here. Power off, FGE interface, and then power on the device. Once you're done with that, click on the fiber cable, connect it with the Gigabyte Ethernet, and in order to make it work, go into the router, say no, enter conf interface Gigabyte 00, shut, and the configs, and then do the same thing in here. Enable the interface. I think it should be 00 as well. So G00, shut, and save the config. So now we can see it's up and running. So that's the end of the video. Thank you so much for watching. Until then, bye from Rogan.